Recording has begun. I'm not sure if you guys heard that or not, but there was a nice, pretty voice this time saying recording has started. So also you guys have noticed there's a slightly later version of Illuminate, a more up-to-date version of Illuminate being run too, so that's kind of nice as well. Today's topic is we had the first part of the inequality workshop on March 18th, I do believe. So this is the second part, inequality workshop part 2. So if anybody wants to watch the first part is on the recording from March 18th. So we're going to be continuing with inequalities. We're going to try to make it as disjoint as possible from that first session so that you can just go watch that recording, and also for the benefit of people who have not yet watched that recording. But here we go. Again, I decided I'm going to do this at the start of each study hall just to make sure we can hit the people who watch the random recordings. But if you've already heard this 3 or 4 times, think of it the way you think of those warnings they give people on airplanes about how to, every time you take an air flight, they have to give you the same safety warnings. So, if you've taken 100 airline flights, you've heard the same safety warnings 100 times. This is kind of like that. So if this is your first edition of this study hall or the first recording you're watching, make sure you pay attention to this. Question submissions. The usual guidelines that we give every session, just very briefly. Okay, first of all, what kinds of questions do we want? Okay, well, first of all, not too general. Okay, for instance, one student in the last couple of weeks submitted something like, I want to know how to, someone said something like, I want to know how to answer math problems better and in a more timely fashion. That is, I can understand this person's concern, but this is way, way too general because this amounts to the entire quant section. So, but yeah, so that's too general. This would be the entire quant section. Okay, but then also you don't want to be too extraordinarily specific either. Like if you say something like, I give the specific problem, what's the difference between choices C and D on this one problem? That's too specific for a study hall topic. Remember the way these are. We have usually between 30 and 40 live attendees, and then we have a few hundred more people who watch this thing in recording form. So what we don't want is a problem that's so specific that it pretty much just pertains to an issue that on one problem between a couple of choices. If you have a question like this, these questions belong on the forums. So the forums are, if anybody doesn't know, it's manhattangmat.com/forums. That's where you should post that kind of ultra-specific stuff. And then also things that are too personal are not super. Ben Aliyah, I can actually incorporate that question into a discussion of one of the following posts, so we can scoop that into it. You shouldn't also ask questions that are too personal. For example, like if you give your scores, study history, school aspirations, etc., that stuff doesn't belong in a study hall. Because remember what this is. This is a study hall that is watched by something like hundreds of people. In fact, I think by now we are probably close to 1,000 if you count viewing the recordings. So we don't want 1,000 people to watch one person's study plan. So again, these questions That's basically inappropriate for a large group like this one. But we have a place for questions like that. Those questions also belong on the forums in the general folder. The general folder is specifically oriented towards questions exactly like this, where people post study plans and general questions and aspirations and things like that. So, also sources, if you do quote a problem, please don't use banned sources. Okay, if you want a full list, you can check the forum out. Check out the posts at the top of any folder in the forums. There's a sticky post at the top of each folder that has a list of sources that are prohibited. Please check it out. In particular, I want you guys to note that you cannot post OG questions. The same restrictions that work on the forum also are in effect here. So we don't take OG problems on the forum because that's a violation of GMAT's copyright, so we don't take them here either. That means if you want to post a material from the OG, that means you need to spin off the question or rephrase it or create your own question that is similar to it. So, but no OG questions. All right, again, this is kind of like when you're getting on an airplane flight, you have to hear the safety talk. This is the safety talk. Everybody give me a smiley face if these items make sense to you. Everything on this page. And then we can start talking about inequality. Okay, let me see the smiley face. So I'm only seeing the smiley face icon from a handful of people right now. Everybody just make sure these things are understood. Okay. Also, I wanted to point out a couple of things before we get going about some submissions that we've already seen. So let me just give you a quick rundown of what people asked about. So today's topic is inequalities, but before we get going, OG stands for the official guide. The official guides are the ones published by GMAT, and also the supplements. When we say OG, that's the same thing. Here's some topics submitted in the last 2 weeks that are already covered in previous study halls. So if any of you submitted these, if any of you are watching, any of the people who submitted these topics, one person asked about rate, time, distance problems. We covered those on April 29th. So you can check out the recording for that date. One person asked about combinatorics. Check out the recording for December 3rd. And then one person asked about equations with absolute values. You can check out February 18th. Note that inequalities with absolute values are also on the same date. Okay. And finally, one person asked about boldface CRs. So that was taught on April the 15th. So if any of you are the people who submitted these topics, these are your reference dates to check for that. Okay, let's go on. Let's do some inequalities. So here's the first problem of the day. What I'll do is, this was one of the submissions from the last couple of weeks. What I'm going to do is give you guys, this is a data sufficiency problem. Go ahead and give this a shot. And by the way, your polling devices should now appear under the names. If any of you did this in the past, this is different now. So take note. please answer the question using the polling A, B, C, D, E buttons. You're not going to see each other's answers, so don't be shy. I'll give you guys about 1:45 to address this question. Go for it. Okay, 1:45 has passed. Please, in the next 15 seconds, pick an answer. Remember, this is the GMAT, so when you take this thing, you've got to pick answers whether you like it or not. So please pick an answer in the next 10 seconds. So the person asking, why can't I see the answers, it's a data sufficiency question. So the question has the two statements. Generally, when we do data sufficiency questions, we don't publish all of those 5 answer choices with statement 1 is sufficient, statement 2 is not, and so on, because in these study halls, we assume basic familiarity with the way data sufficiency works. So if anyone has never seen a data sufficiency problem, admittedly, they might not understand what's happening here. But if you're not sure what's going on here, try to follow. Basically, the deal is that we're trying to figure out whether these statements are sufficient to answer this question. Okay, here's the statistics. 6 of you guys still didn't answer the question. So this is not good from a test-taking standpoint. Remember that when you take this exam, there is no such option as not answering the question. So one of these 6 people is me, but you 5 who didn't answer the question, you got to try. You got to give me some sort of answer here. Okay, now the deal is, as you can see, the responses on this one were all over the place. And the reason why the responses were all over the place is that many inequalities, like this one, can't really be solved with algebra, at least not efficiently. So either, number 1, they just plain can't be solved with algebra, or can't be solved efficiently with algebra. This one's kind of on the borderline between number 1 and number 2. Like, you could probably break these down into a lot of different cases with algebra, but you really, really, really wouldn't want to. So instead, here's the takeaway from this problem. All right, when you see an inequality that combines number properties with inequalities, such as this one, absolute values, powers, etc., things like that, all those things that are in our number properties guide. That's what we mean by number properties. So it's kind of a brief note to that effect. Number properties refers to, absolute value, powers, positive, negative, 0, etc. When you see such an inequality, if you don't figure out algebra, there may not be an algebra way. So if you get stuck on algebra, think about the number types that will affect the quantities in the problem. And does anybody know what I'm talking about? For example, number types could mean positive, negative, 0. Number types could mean integers and not integers. Number types could mean fractions, and so on and so on. Number types. As for the person who said, how could you see if your answer was submitted? I got your answer. Okay. Does anybody know, in the text box, go ahead and type if you know, what kind of number types will have an effect on a problem like this one? Does anybody know? What number types should we consider? Okay, I'm seeing fractions. And then I'm also seeing positives and negatives. Yeah, that's pretty much the deal. By the way, guys, this is one takeaway. Another takeaway is that when you think about signs, you also have to consider 0 as a sign. So, for instance, it's not just positive and negative, it's also positive, negative, 0. But on this problem, here's what we see. We see different hints, and then because of those hints, we've got to consider different types of numbers. All right, one hint is that we're multiplying x by itself up here. Actually, there's two different hints that tell you fractions. The first hint is that you see absolute value of x less than 1. So if you see that, notice that the numbers that do that sort of thing are the fractional values. So you want to think about fractions less than 1. Okay, another hint is that you're also comparing, this is not x squared, but it's related to x squared because you're multiplying x by its own absolute value. Like if x is positive, this is x squared. So, and if x is negative, it's minus x squared. So this is a quantity that's related to x squared. So you are basically seeing different powers of x in the same equation. So both of these lead you to consider fractions less than 1. And then also, if you see absolute values in general, then you know that absolutely, absolutely, on your radar should be positive, negative, and 0. So this is it. The way we attack this, instead of doing algebra, is we just take these number types and we just throw them in and see how they perform. So let's look at statement 1. So statement 1. Okay, notice that x is not allowed to be 0, but we need to try different types of numbers that'll do this. We need to try negative and positive and fractions and things that are not fractions. So here's a sampler. Here's a negative number that's not a fraction. Here's a negative 1. Here's a negative number that is a fraction. We don't need to worry about 0. Here's a positive fraction. Here's positive 1. And here's a positive number that's not a fraction. Okay, now what we do is we've got to pick out the ones that actually matter for the statement. So the ones that don't obey the statement in the first place, we just throw out. So which of these obey statement 1 to start with? So you got to try the plugging for that. You just got to throw them in there and see if they work. So negative 5, this would be negative 25 is less than negative 5. That works. So then we answer the question for that. The question is absolute value of x less than 1? So the answer is no. This gives us a no to the question. Okay, negative 1, this would say negative 1 is less than negative 1. Negative 1 doesn't satisfy the statement in the first place, so we just don't have to use it. If we plug in negative 1/2, this says negative 1/4 is less than negative 1/2. That's not true. So we don't have to use that one either. If we plug positive 1/2, we get 1/4 is less than 1/2. That works, so we use it. Now we answer the question. Is 1/2 less than 1? Absolutely yes it is. So that's a yes to the question. This is insufficient. Okay, smiley face if you guys follow that process. Notice you figure out what types of numbers you got to think about, and then you generate some numbers. You have to be careful to use numbers that actually obey this statement. Because remember, if this statement is a lie, then you don't have to think about those numbers. And then once you find numbers that do, you throw them into the question and you see how they behave. In this case, this is insufficient. Statement 2, let's do the same process. So just in case anybody's checking out this recording and checking in late, these two things don't obey the statement. These two that we just crossed out over there in the first place. Those two. So let's connect those with a little line here. Okay, then let's do it for statement 2. Statement 2, let's try the same numbers. So again, negative non-fraction, -1, negative fraction, positive fraction, +1, and positive non-fraction. Now notice the only reason that 0 is not in this list is because 0 is expressly prohibited by the question statement. Otherwise, 0 would as well have to be in the list. So absolute value of x greater than x. So that's true for the negative values, and that's false for the positive values. So if you do that, by the way, when you plug in numbers, your other goal is to notice things that happen that are obvious patterns. Like in this problem, there's not so much an obvious pattern to what numbers work and what numbers don't. But in this case, there is. You can notice when you do this, this just means that x is negative. If you didn't realize that before, you can just notice that, wow, it works for all the negatives and it doesn't work for the positives. Then you can go back and think about it and say, aha, if x is positive, these will be the same. So if they're different, then x must be negative. Okay, so if we answer those, -5 gives us a no to the question. -1 also gives us a no to the question. But -1/2 gives us a yes to the question. If you combine the statements, the only number in our list that satisfies both of those statements is -5. And then if you're not convinced, if you're still skeptical, and if you still have time, they're both very important criteria. If you're still skeptical, and more importantly, if you still have time, then you can check more numbers. But you'll get a solid no to the question every time. So that's sufficient. So lots of big takeaways from this problem. There's minor takeaways, like the interpretation of this is a minor takeaway. Now here's a little bit of a word of warning. Some people are so focused on algebra that they'll watch this whole presentation of this problem, and the only lesson that they'll draw from it is, oh, if I see this, then I know x is negative. That's true, and that's a lesson you can get, but it is not by far the important lesson. The important lesson is that if you see inequalities that look like this, which don't really admit simple algebraic solutions, then don't bother. Just try plugging in a bunch of numbers and see how they behave. All right, any questions about this problem? Go ahead and type in the text box. Smiley face if you guys are ready to move on. And by the way, Ben Lee, your question can be addressed by this sort of method too. The question that you had before, if you plug in positive, negative numbers into that, you'll figure it out. You'll figure out why it's insufficient. So we'll have some more things that'll help you with that type of problem too, talking about extremes and such. But all right, let me see smiley faces if you guys are ready to check out something else. And yeah, the answer to the problem is C. Let me go ahead and type that. Thank you. The answer to the problem is C. Okay. Let's look at another one. That's this one. This was a submission from one of the students. This is, according to the student, this is a spin-off of one of the OG problems. Remember what we said? That's what you want to do. If you want to write a problem that's like an OG problem, don't submit the OG problem. Write your own problem that is like it and submit that one. So give this a shot, and I'll give you about a minute and a half, and then we will talk about it. Your polling should be cleared out. Again, please answer the question in the polling buttons, not the text box. So A through E buttons at the left. They should be over here. If you don't see them, then take a look underneath the list of names. Here's a timer. Okay, please go ahead in the polling area over there with the A, B, C, D, E. There's still a lot of you blank. The next 10, 15 seconds, go ahead and indicate an answer, please. Here are the results. This is getting better, no problem. So here's your polling results. Let's take a look. Is X negative? I mean, this one I'll go ahead and show you an algebra solution, then I'll also go ahead and show you a number testing solution. So, in fact, let's do number testing first, just because that's the topic that we're on. Although this one admits algebra nicely. So, okay, let me address the question in the text box really quickly. This person is asking, so the way to solve this is to do this. In general, you guys need to be very, very wary of thinking that anything will ever be the way to do something. All right? The whole point of this test is to throw curveballs at people who think there's a systematic way to do everything. You know, because like people come into these things thinking that algebra is the only way to solve these. That's why they write problems like this. These problems are targeted at people who are obsessed with algebra, purposely to knock those people off their pedestals. I mean, that's what those problems are for. They're meant specifically to foil people who use algebra in favor of people who are flexible. On the other hand, there will also be problems that are specifically meant to foil people who pick numbers. You know, there are also going to be problems that are specifically meant towards algebra types. So, in general, no matter what the specifics are, the answer to, is this the way to solve this problem? The answer is no, it's not. It's a way to solve the problem. One of many. So when you approach these things, you really do not care what is the best method or what is the fastest method or what is the whatever method. All you care about is, here are a bunch of ways that I can throw at the next question. Okay, smiley face if you guys understand this point. I mean, flexibility is the idea here. It doesn't, you don't want to have one approach. So, and also when you take this test, you are absolutely not worried about efficient. Okay, if you find something that works, you do it, as long as it doesn't take like 10 minutes. In other words, if you have a solution in your hand, you do it and you move on. You do not sit there and wonder whether there is a better way. That will destroy you. So very important. Okay, number testing, again, we've got powers, and we've got odd and even powers. So let's test different types of numbers. Let's try, again, positives and negatives and zeros and fractions. Okay, so statement 1. Let's try some numbers. So same numbers we did before. Let's throw them in it again. That is not supposed to be the equal sign. There you go. And then we try 0, because 0 is not prohibited this time. There's our list of numbers. That was not supposed to be 15. Illuminator is not my friend today. Okay, so if we try these numbers, then here's what happens. -5 works in the statement, so we do need to think about it. -5 is definitely, because you don't have to think about the values of these numbers. I mean, -5 cubed is a much larger negative number than this is. So when you subtract, it'll wind up positive. So that actually doesn't work. Sorry, I was reading the sign. I was reading the alligator the wrong way. This doesn't work in the statement. Because if you subtract smaller negative number minus larger negative number, that is positive. So this doesn't work. Okay, if you do -1, then that is 0, so that doesn't work in the statement. -1/2 does work in the statement. This would be -1/8 plus 1/32. That works, and that's a yes to the question. 0 doesn't work in the statement. 1/2 does not work in the statement because 1/2 cubed is bigger than 1/2 to the 5th. 1 doesn't work in the statement, but 5 does. And that's a no to the question. So this is insufficient. It took a while to get there, but we're there. All right, statement 2. Let's grab this list of numbers and put them there. Okay. Those are the same numbers. So statement 2, let's take a look. X² minus 1 has to be negative. Again, there are algebraic ways of solving this, but that's not where we are right now. So -5 does not work in the statement. -1 doesn't work in the statement. -1/2 does. That's a yes to the question. 0 works. That's a no to the question. So that's insufficient. Okay, but if you have together, what you're going to find out, and you can investigate depending on how much time you have to do the investigating, but the only the numbers like -1/2 will work. So that's sufficient. So you can use number picking to figure that out. Any questions about that method? So the answer should be C. Smiley face if you guys understand the number picking method. Okay. Now for the new, we can also address this problem with algebra. So let's do that. Make sure that you know how to solve an inequality. I mean, to solve any inequalities that are not linear, I mean, you know, as long as it's not 2x plus 3 is greater than 5. To solve inequalities with factoring, or fractions, etc., here's the protocol. To solve those, what you do is you solve the corresponding equation. In other words, you pretend there's an equals sign. Then what you do is you set up a number line with the following, with points, with the solutions to the equation, and then also with any numbers that are undefined, like any numbers that create problems in the equation. What I mean by problems, usually 90-odd% of the time, this means division by 0. And then you just test the regions of this number line. So let's do this for statement 1 and 2 here. Here's how this works. Let's move this up here a little bit. Okay. Just compress this text so that we can fit some solutions down there. Okay, for statement 1, for both statement 1 and statement 2 here, you just do some factoring. So statement 1 is going to factor, you can pull out x cubed, and that gives you 1 minus x squared is less than 0. It's going to take a second for the exponents to appear, so apologies. X cubed and 1 minus x squared. And then you can factor the latter into 1 minus x, 1 plus x. So again, here's the exponent on its way. There's the exponent. So there's no problems, there's no division by 0 in this problem or anything like that. So we don't have to worry about that. But the solutions are 0, 1, and negative 1. But solutions are negative 1, 1, 0, and 1. So we set up a number line, and we put those numbers on the number line, and we test the regions. So 3 numbers on the number line are negative 1, 0, and 1. Those are on there. And then, since this is strictly less than, we don't have to worry about these numbers. If this were less than or equal to, we would also have to consider these numbers themselves, because that's where these are equal. But since this is strictly a less than equation, we don't worry about these, we just worry about the regions in between them. So in this region, we plug in a number, any number in that region, into the inequality. If we try negative 2, we get negative 8 plus 32. That doesn't work. So negative 2 is a fail. So we'll put a frowny face for negative 2. It doesn't work. In this region, we need to try something. We need to try something between negative 1 and 0. So the number we try is anything in there. Like we can try negative 1/2. If you plug negative 1/2 into the original inequality, you get negative 1a plus 1 over 32. That is negative. So this works. And then we need to try 2 more areas. If we try this area, we can plug in positive 1/2. If we do that, it does not work. And then finally, for the last region, we try something in there such as like 10 or 1,000 or anything in that region. So if you try 10, it definitely works. 10 cubed minus 10 to the 5th is less than 0. So here's your solution to your inequality. Solution is these 2 regions with smiley faces on them. So either x is between -1 and 0, or x is greater than 1. So again, let's recap. These are inequalities. So remember, when you find solutions to the equation, you're not really finding the solutions to this. Those are the solutions to if these were equal. So those are not the actual solutions because this is an inequality, but what those are is they are boundaries of the actual solutions. So when you solve the equation, that just tells you where to put boundary lines on a number line. Once you do that, you have to test the different regions that are roped off by plugging into the original equation. Into the original problem. So smiley face, if you guys understand this general procedure. This, by the way, is what you would find in like a high school algebra textbook dealing with these inequalities. So if you have lots of trouble with this approach, you might want to go ahead and check out something, a standard resource like a high school algebra book, where it shows you how to do this stuff. But smiley faces, if you're okay with that. Questions, if you got them, in the text box. So that takes a while. It shouldn't take you that long to do it, but it takes a while to draw it here in the study hall. So what I'll do is I'll just report what happens with the other statement. But notice this statement is insufficient because that first group of numbers is a yes to the question, and the second group of numbers is a no to the question. If you try statement 2, try it at home, you should wind up with this. So this is insufficient because some of these are negative and some of these are positive. But if you have them together, the only way you can satisfy both of these at the same time is if what? Go ahead and type in the text box, please. What are the only numbers that satisfy both of those equations at the same time? Text box. Yeah, there's one response. We got a couple other people typing. Yeah, well, so the sample number is -1/2, but in general, if you solve this with algebra, you should just be thinking about these intervals. So then these numbers work in this statement also. So those are a solution. But these numbers don't. These numbers are not between -1 and 1. So the only way you can satisfy both these statements at the same time is to be between -1 and 0. So that's a yes to the question, so that's sufficient. Questions about this problem? Type them in the text box if you've got them. Otherwise, we'll move on. By the way, a comment for the submitter of this question. the manipulations that you did are actually the reason the question you submitted will actually be answered in the next problem. So we'll get there. But, okay, let's move on. Before we move on to the next inequality, let me just give you a brief rundown of how to combine inequalities, because there's really only one rule you've got to know about combining inequalities, and I think this was in our March 18th study hall. So let me check this really quickly. Did we do that in March 18th? No, we did not. Okay, so we have not covered combining inequalities yet. So let's talk about this from scratch. All right. Combining inequalities. Can I add the following inequalities together is the question. So here's 3 sets of examples. Can I add those? Can I add these? And can I add these? Okay, what do you guys think? I'm clearing out the polling. In the polling box, you're going to see some red X's and green checks. If you think you can do this, green check. If you think you can't do it, red X. Okay. What about this one? If you think you can add these, green check. If you think you can't, red X. And what about these? If you think you can add those, green check. If not, red X. Okay, so most of you were on the mark here with this, some of you not. It might help to think of this in real life terms. In real life terms, this could be something like, I have less than $20 and my brother has less than $30. Okay, well if that's true, then you definitely know that together we have less than $50. So you can add that. Same principle applies here. Here, if I have more than $20 and my brother has more than $30, then you can definitely add those. We have more than $50 between the two of us. But here, if I have less than $20 and my brother has more than 30, then you can't relate it to $50. Because, for example, if I have $19 and he has 1,000, then we have more than 50. If I have nothing and he has $31, we have less than 50. So in this case, you can't tell whether X plus Y is less than, greater than, or even equal to 50. So there's a rule here that we've discovered, which is that you can only add inequalities if the alligators face the same way. Okay, if anybody doesn't know what alligators are, if you didn't watch the March 18th inequality workshop, give me the not smiley face over there, the face that's not smiling if you don't know what I mean by an alligator. Okay, here's the executive summary of that. Back when I was in 3rd grade, maybe it was 2nd grade, maybe it was 1st grade, it was some really small grade, they introduced us to inequalities. And they showed us these inequality symbols. And here's how they introduced it. They introduced it as, this is an alligator, Well, we weren't solving inequalities, but they told us what the symbols meant. Maybe it was third grade, but I mean they just taught us the less than, greater than symbol. Okay, the alligator is hungry, so therefore it eats the bigger number because it wants a big meal. So hungry alligator, it eats the bigger meal. That's how the inequality sign works. So what's the point? The point is this. In these study halls, okay, if you see this, or this, or if you see this, or if you see that, then those are called alligators. Whereas if you see something like plus, minus, or 0, those are signs. So just make sure that you guys understand that if I say the word sign, I am never, ever, ever, ever talking about these. Because otherwise, if I don't do this, there will be eternal confusion. Because if I say flip the sign, no one will know what I'm talking about. Half the people will think I'm talking about switching these around. The other half of people will think I'm talking about switching pluses and minuses. So smiley face, if you guys understand this, these, when I say these are alligators. And when I say signs, I am only ever talking about pluses and minuses and zeros. So very important. Okay, you can only add the inequalities if the alligators face the same way. All right, so the question that crops out of that then is, what do I do if the alligators don't face the same way? Because you can't add them, right? So what do I do if the alligators don't face the same way? Well, if you really wanted to try really hard, you could make rules for subtraction, but that would be kind of annoying and obnoxious. So instead, let's take that example. And can anybody tell me what I could do with that in the text box? What could I do with those? Yeah, you make them face the same way. So if they don't face the same way, make them face the same way. So there's two ways to do that. Number one is just to reverse the whole thing. You know, so for example, if you have this is less than that, that's the same thing as saying that is more than this. The other way to do it, as you guys are saying in the text box, is you can just multiply by a negative sign. So multiply by -1. Remember that when you multiply or divide by negatives, flips the alligator around. So let's just do this both ways. If you want to do it the first way, then you can just take the first statement and just flip it around. So 20 is greater than x. Then we'll keep the second one the same. If you add that, then you get y plus 20 is greater than x plus 30. And if you want, you can simplify that. So that would give you y is greater than x plus 10. The other way to do it is you could multiply by -1. And that would give you negative x is greater than -20. Just to underscore that fact, I'll make a red alligator for that case. And then you leave the other one the same. Notice you don't do it to both of them, because otherwise you have the same issue you had to start with. But you do this to one of them, and then they face the same way, and you can just add them. So in this case, you get y minus x is greater than 10. Notice that these are the same. There's no difference between these two. Okay, smiley face if you guys understand how to add inequalities. So notice that you should never have to subtract inequalities. If you're ever in a situation where you think you would want to subtract, don't subtract. Just do one of these two things and then add. All right, the other way to combine inequalities, which is much less common, but which is worth mentioning for the sake of completeness, is what I call making a chain. Much less common, but also worth knowing, is you can combine inequalities by connecting the links in a chain. For instance, if you have x is less than y and y is also less than z, then does anybody know what we can say? Text box if you know. Yeah, you guys are nailing it, absolutely. Yeah, here's your link. That link is kind of like saying, I mean, again, in real life context, you guys would all nail this, no questions asked. Kind of like in a real life context, you guys would all know if x is if I have less than $20, my brother has less than $30, we have less than $50. But for some reason, in inequality symbols, a lot of these become harder for people. But the combined version of this is that x is less than z. So, I mean, you can write those as a sandwich inequality. A couple of you are putting in the box x less than y less than z. That's absolutely true. But if you write that, the only thing there that is new information is this fact. So, this is like saying my brother is shorter than I am, and I'm shorter than my cousin, so my brother is shorter than my cousin. If you do it with that kind of real life stuff, total common sense, but still worth going off of. Okay. So you might face alligators the same way and add, and you might connect the links to the chain. Any questions? I think there's one person typing a question. I'll try to answer it in midstream. Let's do a problem. I'll give you, this one is from GMAT software. So here's the problem. I'll give you the polling tools again. Again, please answer using the A through E buttons. Thank you. And I'll give you a little bit more time this time, like maybe 2 minutes and 15-ish. Try it. Okay, timer's running out. We're about at the 2.5-minute mark here. So in the next 10 to 15 seconds, please pick an answer. Thank you. Okay, the class, this is normally a pretty hard problem for people, so the class did very well on this. There's your polling results. So this is the correct answer to this problem is indeed C, so this is actually fantastic. I have a feeling that some people probably took a hint from the fact that we just spent 15 minutes talking about how to combine inequalities. So therefore, in other words, you know it's going to be C versus E yeah, well, we're not going to talk about how to combine inequalities for so long and then give you a problem that has nothing to do with combining inequalities. So if you were clever that way, then great, but just make sure that you get the takeaways that you want to get here. Okay, as far as the individual choices go, this is mostly a number properties type question. So statement 1, for example, you can rearrange this to m is greater than 3z. So if you try m and 3z, this doesn't tell you what the signs are. Remember what signs means? Signs means positive, negative, and such. So it's not going to work. If m and z are negatives, if you pick two negatives such that m is greater than 3z, then that's a no to the question. But if you pick two positives such that m is greater than 3z, then that's a yes. So that's insufficient. One person in the text box is saying there's no relationship. That's a little bit exaggerated because that, after all, is a relationship. But yeah, it's not the kind of relationship that we need. Okay, statement 2, pretty much exactly the same thing. In fact, it is exactly the same thing. Statement 2, you can rearrange to 4z is greater than m. So same reasoning, you could still have two positives and you could still have two negatives. So any questions about that? That's also insufficient. So smiley face if you guys are okay with those two statements being insufficient. And then we'll move on to addressing them together. Okay. Together. Well, this is the beautiful situation. If you have them together, then you can just add them. So if you've got m is, well, there's actually two ways to do this. So let's move this over there, and I'll show you both ways. So let's put a big divider here. Here's a divider. Okay, if you've got them together, one way to do it is just to add them. By the way, a lot of these problems, you guys, a lot of it's going to be, I don't know what else to do here. I mean, this is two inequalities, and the alligators already face the same way. So this is the perfect setup for adding together two inequalities. Like, this is the exact situation in which you want to do that. So you might as well do it. You know, it's almost like if you see a ball and you see a basket, you might as well throw it through for lack of anything better to do with it. So if you have that, let's just add them. So m minus 3z is greater than 0, and then let's just rearrange. I'm not changing anything here. I'm just going to write the m's underneath each other. So make it easier. If you add those, then the m's go away and you wind up with z is greater than 0. So the question is this good enough to answer the question? What do you guys think? And if it's yes, go ahead and type in the text box Y. Okay, so by itself, this statement is not good enough. This is where, if the person who submitted the last question, if you're watching this right now, this is the problem. That statement by itself is not good enough, but you don't have it by itself. Remember, don't forget, if you combine two equations or inequalities, don't forget about the original equations or inequalities that you combined in the first place. In other words, this is not, once you get to this point, it's not just z is greater than 0. Like, once you get to this point, you still know that z is greater than 0, and you know that m is greater than 3z, and you know that 4z is greater than m. So once you get to this point, you know z is greater than 0, but you also know that m is greater than 3z, and you also know that 4z is greater than m. So, well, if you know all of these things, then you know that m is also positive. Here, z is positive, and if m is greater than 3z, then m is also positive, which you didn't know in statement 1. So that's sufficient. Okay, it appears that people are playing around on the board, so I'm going to disable that. All right. Let's see. Okay. Does everybody understand this approach? This is a really, really big deal. Because, and this is also the person who submitted, I'm going to switch over to this question real quick. The person who submitted this question, this is the mistake you made with your work here. The reason I'm not addressing what that person did is because it was a pretty inefficient approach, but that was the problem. The problem was you were combining two equations or inequalities and then forgetting the ones that you combined in the first place. So there you go. In the previous question, doesn't do you much good because nothing cancels out if you add those together. I mean, if you take a look at these, the question is, can you do that here? Adding these is not going to do you a whole lot of good. You could factor by grouping if you did, but that would be a lot harder than just combining two statements that are already there. So, okay, since that's a handwritten question, you can post it on the forum. By the way, Ben, if you have more questions about that, you can post it on the forum. Okay, the other way to do it, quick rundown, is you can make a sandwich. You can make a chain. So let me show you how that works. So you make a chain of reasoning. The way that works is you've got m is greater than 3z, but you've also got 4z is greater than m. So there's your link. So therefore, 4z is greater than m, which is greater than 3z. This means that 4z is greater than 3z. Is this stupid? Like, do we always know this, or does this tell us anything in the text box? What does this tell us if it tells us anything? It's not something we always know. This tells us that z is positive. Because for the person who said it, we always know that. If z is 0, this is a lie, and if z is negative, this is a lie. So if we have this, then that actually means that z is a positive number. So good times. Therefore, c is positive. But then notice what happens, right? You've got that right there. So that means that these two bounding values are positive. So let's mark that. This is positive. and that's also positive. And so that means that m is stuck between two positives, so m is also positive. And we're done. Any questions? If you got questions, type them in the text box, smiley face if you're ready to move on. See a few more of the smiley faces if you guys are ready to hit it here. Okay. Good. Let's look at another one. Try your hand at okay, the question in the text box, this is still the wrong type of question to be asking. You're still trying to optimize approaches here. You can't think about it this way because the test is not going to be that predictable. There's no looking for the best. You just, with the lesson that you've got to get out of this is you've got to understand number picking and you've got to understand algebra, and you just have to throw them both at it and see which one sticks. You're not trying to optimize everything here. That's way too strong of an expectation. It will not work. Because notice how we attack this, right? This is like a hybrid approach. We didn't do algebra with the first two statements. We just picked numbers. Because if you look at these things, I mean, if you try to do algebra with this, you could push n and z around forever and nothing will happen. But you can just look at it and say, okay, look, if these are negative, it's a no. If these are positive, it's a yes. So that's just what works. You don't have to premeditate that. You just have to try it, you know. Because if you try algebra with statement 1, it will get you nowhere. So you just quit and you throw numbers at it. Whereas picking numbers for statements 1 and 2 is a little bit hard, but these look like they were handed to you for the specific purpose of combining them. So you just go for it. But the deal is to have as many approaches as you can have. That's basically the story. Okay, try your hand at the following. This one combines an equation and an inequality. I'll give you about 2 minutes. All right, a majority of people don't have an answer yet, so please pick one in the next 15 seconds. Thank you. Okay, last call for answers from Yvette, Margaret, and Sean, who don't have answers yet. Last call. All right, here are your statistics. There's still, there's one new person who doesn't have an answer. All right, here we go. Surprisingly, the popular choice A here is not the right answer. So this one we need to talk about. But let's go with statement 1. Statement 1 is 2 inequalities. There's a couple ways that you could do this. Let me give you 2 different approaches, which just use elements that we've already seen here. All right, so first approach we can use is the combining inequalities approach. The alligators are already the same. So note that you've got the same alligator. If we can turn 3y into 3y, we can get rid of y. Because this is 3y on the right, so if you also have 3y on the left, then you can get them to go away. So let's do that. If you have negative 2x is greater than 3y, we'll just leave that alone. But if you multiply number 1 by 3, here's what you get. So then if you add those together, you get this. You get negative 2x plus 3y is greater than 3y. The 3y's go away. Negative 2x is greater than 0. If you divide by negative 2, you get x is less than 0. That's a yes to the question. By the way, are you guys all absolutely crystal clear on what you do if there's an if in the statement like that? If you are like 100% sure that you understand that, then give me the smiley face. If you are 99% sure or less, then give me the other face. Okay, so enough people are not clear that let's take a detour and do a treatment of that. Okay, what do you do if you have an if in data sufficiency problems? Okay, well, let's say you had something like this. For some reason, when there are words there, people seem to get this instinctively, so let's do that first. You know, so let's say we had this question. Okay, a stupid question, but in this problem, when is n a positive integer? Go ahead and answer that for me in the text box. In this problem, when is n a positive integer? Always, right? So make sure you guys understand that. I mean, if for some reason, if there are words here, then people seem to instinctively grasp this. But then for some reason, when those are not words, when those are equations instead of words, it's very much harder for people to process. So if you have something like this, if like, what was the problem? The problem was if negative 2x is greater than 3y. So is x negative? This is exactly the same thing. So if you have, yeah, if it's in a data sufficiency problem, absolutely yes. So if you have these two statements, then again, this is always true. So here's the way to think about this. All right, again, this guy over here, this orange guy, is always true. So here's the way to think about this. You should rephrase it. You think of it this way. The question part is really just, is x negative? Because the rest of it, as we've seen, is not really a question. It's really just telling us stuff. Then statement 1 is blah, 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 and that statement. That's the way to think about that. Similarly, if you have statement 2, that's whatever the blah, blah, blah is. And that if part. So this is the way, whenever you've got an if in the statement, this is what you do. Okay, you can think of it as a component of both statements. So in words, if there's a data sufficiency with an if, in a DS prompt, then you can consider to be part of both statements, each of the statements. So very important takeaway for you guys if you didn't understand this before and now you know this, this is a takeaway. So let's attack this with that in mind. Notice that's why we're doing what we're doing, right? So let's just the color code. This is the orange statement, which is always true. So you can use it no matter what. So let's rephrase. Let's kill those statistics here in the corner. We don't really need those anymore. So the way you should think about this, and you may even want to write this on your notepad. It really doesn't take that long to do it. It really is x negative. Statement 1 is really telling you y is greater than 0 and that. And statement 2 is really trying to tell you that whole ugly thing and that. Okay, so back to statement 1. The other way you can do it is think about number properties. You can actually just think about it if you understand these properties well enough. You know that y is positive. So you've got negative 2x is greater than a positive number. Therefore, if you're greater than a positive, you must be a bigger positive. And so x is negative. All right. That's all for statement 1. Now, what about statement 2? The question is, how do I combine an inequality and an equation? Because that's what this is, right? You've got, that's an inequality, but that's an inequality and an equation. So here's your equation, and here's your inequality. Does anybody know how to combine those? Text box if you do. Substitution is one way, and you got to be real careful about the direction that you substitute. Or I am not, Deepak, I'm not quite sure what that means. AX plus 3y. Okay, let me show you 2 ways to combine an inequality and equation. So, and then we're running over time here a little bit, so this will be the last topic of the day. So it doesn't always happen that way. But yeah, you guys basically have the idea, although I was expecting words and not numbers so much, but okay. Okay, the first thing you can do if you want to combine an inequality with an equation is you can add them. Okay, so note that alligator plus equal sign gives the same alligator. All right, for instance, if you have this and this, if you combine those, then you're going to get this. Again, in real life terms, this is total absolute common sense. If my brother has $30 and I have less than 20, then together we have less than 50. That should make perfect sense. So the same goes for all 4 alligators. Less than or equal to, greater than or equal to. They all add to an equal sign to give the same alligator. So again, the real life examples make this. If you don't, I mean, I would not just memorize this if I were you guys, because if you do, it'll evaporate from your brain in like 24 hours. So instead, just think of that real life example. I have less than 20 bucks. My brother has 30 bucks exactly. So we have less than 50 bucks. Same goes for the other. Same goes for the other alligators. So that alligator, and that alligator. There it is. The other way to do it is substitute. So if you substitute, then you got to do it in a specific way. You cannot plug an inequality into an equation. So what you do is you have to solve for a variable in the equation, and then you have to plug into the inequality, not the other way around. So let's just work both of these, and then we're going to call it a day. So here's the first one. The first one is you got an equation and you got an inequality. And then notice the deliciousness here. You've got rearranging some elements here. Okay, I mean, notice the other piece of deliciousness here, which is that you've got this and this. Actually, we want y to go away. So what we want to do with that is we want to be strategic here. That's 5y and that's 3y. So we would multiply this one by 3 and this one by 5. So that'll give us equal y's. First one times 3, so that gives you 6x plus 15y minus 60 is 0. Second one times 5, that gives you 15y. Negative 5, positive 5, because it's on the other side. So we have negative 10x is greater than 15y. And we can add them. So that gives us negative 4x plus 15y minus 60 is greater than 15y. The 15y's are gone. So negative 4x minus 60 is greater than 0. Negative 4x is greater than positive 60. So divide by negative 4, notice that flips the alligator. And so that gives us x is less than negative 15. That's sufficient because it has to be negative. All right, smiley face if you guys understand that solution. It's a little bit obnoxious because you have to do this multiplying. But let's do a substitution. In that case, we need to solve the equation. So we want to solve for y because we want it to go away. So if you solve that for y, you get 5y is 20 minus 2x. So you get y is 4 minus 2/5 x. So then you need to plug into the inequality. If you do that, you get negative 2x is greater than 3 of those. Well, the question in the text box is, can't we also solve for x? Well, if you solve for x, then x will go away. So that's not what we want, because the question is about x. So the question the other question in the text box is, do I have recommendations on how to study this stuff? That's basically everything we ever do, is recommendations on how to study this stuff. I mean, there's no short answer to a question like that. So unfortunately. Okay, if you finish solving this, you get negative 2x is greater than 12 minus 6x over 5. Multiply by 5 to get rid of the fractions. Negative 10x is greater than 60 minus 6x. And the same thing. So you've got negative 4x is greater than 60. Okay. So there. All right, there's that. And then what I want to show you guys, we're definitely over time, so we're going to cut this at this point. But I do want to show you a quick stunt to close out the day, just for kicks. All right, here's a quick stunt. All right, if you remember this problem, then taking these two statements together, if you take 5 times the first one, that gives you this. And if you take 4 times the second one, that gives you this. And then if you add them, that gives you m plus z. Sufficient. All right, that's it. There's your stunt of the day. We are definitely out of time. Let me look at these couple questions that are in the text box, and then we'll cut it. So the problem was this one. What do you mean, where did we put the 20? I mean, this is, you mean here? That's just basic algebra solving. When you pull the 20 over, it's a 20 on this side. When you divide by 5, it becomes a 4. So if you work out the steps, if you work out the algebra yourself, that should be what you get. I mean, it starts as 20, but you have to divide by 5. So you wind up with 4. Okay. What is this? And then Deepak, that big paragraph length question, the question is about X, so you should not just think about Y. That's a very, very bad precedent. Because for example, if I switch this to a less than alligator, then you will crash and burn with that approach, because the same statements suddenly become insufficient, both of them. So that is, yeah, no, guys, it's a stunt. Yeah, you need to make sure they're insufficient on their own. It's just a cool trick that I wanted to show you to close out the day. Well, we don't need to overanalyze it. Okay, but yeah, you would have to yes. If you're going to do this, you'd have to make sure that if you're going to do this thing, you got to make sure that they're insufficient first. So, right. So just for posterity, let's put that on there. After making sure they are individually insufficient. Okay, we are over time here, so let's go ahead and cut the rope. And remember, we've got forums. If you have those individual, very specialized questions, that's where you take those. And then, as usual, we'll have the usual warning at the start about what to submit and what not to submit. But, all right, recording is going to